Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring scale factor and dilations. Let's start with a few definitions. So let's start with the definition for scale factor. In similar figures, the scale factor is simply the ratio of the corresponding sides. And we want to always compare the new side to the original, or the image to the pre-image, same thing. So, for example, in these two rectangles here, we have the pre-image, which is our smaller rectangle, and our new image. If we were going to find the scale factor, let me draw this side, that's 18, corresponds to this side, which is 6. So I'm going to form a ratio where I take the new side, 18, and compare it to the old side, which is 6. And if I write that in simplest terms, 18 divided by 6, I get 3. So there's a scale factor of 3. In other words, the new rectangle is 3 times as large as the original rectangle. Now, a dilation is a transformation that produces a similar figure that either enlarges, gets bigger, or reduces, that gets smaller, the size of the original figure by a given scale factor. To dilate a figure, you simply multiply its dimensions by the scale factor. So if you had a triangle with sides 3, 4, and 5 that you wanted to dilate by a scale factor of 2, your new rectangle, you would just multiply each of the original sides by the scale factor, and it would become 6, 8, 10. So you're just multiplying each side by that original scale factor. Now, an enlargement occurs when the scale factor is greater than 1. A reduction occurs when the scale factor is between 0 and 1. So, tell whether each scale factor will enlarge or reduce the figure. So if we have a scale of 3 over 2, that's the same thing as 1.5. So if your scale factor is larger than 1, it will enlarge the figure. Okay. If you have a scale factor of 1/8, 1/8 is a number that's bigger than 0, yet smaller than 1. So that's going to reduce the size of the original figure. All right. So in example 1, it says find the scale factor for each dilation and then determine if it was an enlargement or a reduction. So we have quadrilateral A, B, C, D, and we produced another quadrilateral A prime, B prime, C prime, D prime. Well, you can clearly see that it is an enlargement. So my scale factor, I know, is going to be bigger than 1. So remember, you're going to take corresponding sides. So AB would correspond to A prime, B prime. And you want to take the new, which is 3.6, over the original, which is 1.2. Now I'm going to multiply those both by 10 to make this easier to divide. So this would be 36 divided by 12. And that is 3. So our scale factor is 3. Sure enough, we got a scale factor larger than 1. All right, problem B. We have triangle XYZ is transformed to create triangle X prime, Y prime, Z prime. What is the scale factor? So I want to compare corresponding sides. So side XY would correspond to X prime, Y prime. So we're going to take our new over our original, and I want to write this in simplest form, so I'm going to divide them, both the numbers, by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So our scale factor is 2/3. Now 2/3 is between 0 and 1, so that's a reduction. All right. Here we have we have a circle with a radius of 2. And then we get a new circle with a radius of 1.5. So I want to compare my new to my original. Now, when I'm taking 1.5 and dividing it by 2, I'm taking a half of 1.5. So I usually think of money. $1.50. If I took half of $1.50, I would have 75 cents. So 1.5 divided by 2 is 0.75. So because that's bigger than 1, bigger than 0 but smaller than 1, that would be a reduction. All right. Now be very careful in this last example. Our pre-image is triangle ABC, and we have our image that has been flipped around. So we need to be careful when we're comparing corresponding sides. So if I say wanted to compare the shortest side on this triangle, that would correspond to the shortest side on this triangle. So just make sure that when you mark corresponding sides, you mark the correct one. So you're going to take the new, which would be 9, over the original. Now those will both divide by 3. So 9 divided by 3 is 3, and 15 divided by 3 is 5. So that is a reduction. All right, example 2. Dilate each of the following by the given scale factor and then record its new dimensions. So if I have a square that has a side length, each side length is 12 inches, and the scale factor is 1.2, that means I'm just going to take my original dimensions and multiply it by 1.2. So that would be 2 times 2 is 4, 2, drop a 0, 4, 4, 1. Move my decimal in one place. So my dimensions of my new rectangle would be 14.4 by 14.4 inches. All right. In problem B, we have a rectangle with a sides of 45 inches for the long side, 30 inches for the short side. Now our new rectangle is going to be 4/5 of the sides. So I'm going to take the large side and multiply it by my scale factor. So let's see, 5 goes into 45 9 times. 9 times 4 is 36. And then I'll take my second side, 30, and multiply it by the scale factor. 5 goes into 36 times. 6 times 4 is 24. So this would be a 36 by 24 inch rectangle. All right. Pause the video and try problem C on your own. When you're ready to check your answer, press play. All right, welcome back. I took my first side and multiplied it by 5 over 2. 2 goes into 36 18 times. 18 times 5 is 90. And then 12 times 5 over 2. 2 goes into 12 6 times. 6 times 5 is 30. So my new rectangle would be a 90 by 30 inch rectangle. All right, problem D. We have a scale factor of 0.75 and we have a square. So in the original square, the sides are all 24 inches. So to form my new square, I'm going to multiply 24 times 0.75. Now you could put that in your calculator, but for me, I think it's easier to write 0.75 as 3/4, and then just say 4 goes into 24 6 times, and 6 times 3 is 18. Then I don't even have to get my calculator out. So this would be 18 by 18 inches for my new dimensions. And that concludes today's lesson, scale factor and dilations.